Welcome. Today we will understand about O2 sensor, that is oxygen sensor. In this video we will learn what is oxygen sensor, how does it work, why do we need oxygen sensor, what are the types of oxygen sensor. In the earlier MAF sensor video, I had explained we use oxygen sensor to determine AFR ratio, that is air fuel ratio. Give me 2 seconds, I'll bring my whiteboard to give you a detailed explanation on O2 sensor and the working of the O2 sensor. Give me few seconds, I'll bring my whiteboard to explain O2 sensor in detail and its working.
20 minutes later.
Now, I have written a block diagram to explain O2 sensor. In this block diagram, the first part is intake system. In this intake system, we have atmospheric air, air filter and MAF or MAP sensor. And in the second part, we have engine with the fuel injectors and spark plug. And the last part is exhaust system. In the exhaust system, we have O2 sensor, catalytic converter and exhaust pipe. In the earlier video, we understood for AFR ratio, we need stoichiometric ratios of fuel and air. For reference, I will take petrol, which is 14.7 parts of air and 1 part of fuel. Through the MAP sensor, we are getting the mass of air that is entering the engine, and via O2 sensor, we are calculating the amount of oxygen that is left behind after combustion. We also understood air fuel mixture can be a rich mixture or a lean mixture, right? Now, how do we know whether mixture was either rich or lean? This question comes to our mind. That's where our O2 sensor comes into play. Oxygen sensor, as we know, measures the amount of unburnt oxygen after the combustion. By measuring the amount of oxygen unburnt, we will know whether the mixture was rich or lean. I will clarify this with the graph here. Here, as you can see, we are seeing a sinusoidal waveform. And here maximum 0.99 volts and minimum 0 volts, and in some sensor it can be minus 4.5 to plus 4.5 or minus 0.5 to plus 0.5. This can vary depending upon the manufacturer. Now for the explanation, I will consider these numbers. Here 0 volt represents the rich mixture and 0.99 volt represents the lean mixture, and the middle ground, that is 0.45 volts, represents a perfect stoichiometric ratio. From this graph, we are understanding whenever the oxygen concentration is less in the exhaust, the O2 sensor output is also very low, that is near zero, and as the oxygen concentration increases, the voltage output of the O2 sensor also increases. And when there is a highest amount of oxygen, that means we have very less fuel, that represents the lean mixture. Here the ECU, engine control unit, with the help of the O2 sensor is always adjusting the fuel to keep it in the perfect stoichiometric ratio. That is, whenever the engine goes into a lean condition, it tries to add a little more of fuel, and whenever the engine goes into a rich condition, it tries to reduce the amount of fuel. That is, ECU is always adjusting the amount of fuel that is injected to engine with the feedback of O2 sensor. That's why we are getting a closed system here. And when it comes to the types of oxygen sensor, we have two types. One is narrow band oxygen sensor and another one is wide band oxygen sensor. In the narrow band type, the voltage output range of the O2 sensor will be between 0 to 1 volt, that is, voltage scale is less, and we get more accuracy in this small amount of voltage change. Narrow band type is widely used in automobiles. The advantage of having a narrow band sensor is it is good for achieving perfect stoichiometric ratio. The drawback of this sensor is it is bad in boundary condition. That is, when the engine goes to extreme condition, whether it is lean or rich, it struggles to bring back the stoichiometric ratio to perfect. And the second type is wide band oxygen sensor. In this, we have the output scale from 0 to 5 volts. That means we have more number of voltage divisions. This type is purely used for motorsports applications or tuned engines or special applications. Using the wide type, our AFR table will be more accurate. It will include many parameters such as altitude, temperature and the octane rating of the fuel. Thus, a tuner can extract the maximum performance out of an engine. Here, I have written upstream oxygen sensor and downstream oxygen sensor, right? What happens is manufacturer use one sensor before catalytic converter and one sensor after catalytic converter. That is because catalytic converter is used to remove few harmful gases from the exhaust system so that it meets the emission norms and cleaner air is released into atmosphere. Inside catalytic converter, the oxidation of carbon monoxide and nitrogen oxide happens. This releases carbon dioxide and nitrogen dioxide into atmosphere, which is much safer compared to carbon monoxide or nitrogen oxide. Also, in two-wheelers, we majorly observe one or two oxygen sensor, and when it comes to car, depending on the number of cylinders, they can either use 2 sensor or 4 sensor or 6 sensors. Also, in oxygen sensor, we have two types, that is 3-wire oxygen sensor and 5-wire oxygen sensor. The 3-wire is non-heated oxygen sensor and the 5-wire type is heated oxygen sensor. Now we should know the oxygen sensor has an operating temperature around 300 degrees Celsius or more than 300 degrees Celsius. That means the oxygen sensor starts working only after the exhaust gases reach the temperature around 300 degrees. As we know, when we start an engine, it will be cool. That is, exhaust gases will also be at the lower temperature. So we won't be able to calculate AFR ratios while idling. That's why modern engines come with the heated oxygen sensor. That means heater coil will be wound around the O2 sensor and it heats up the exhaust gases near the O2 sensor, thus helping the ECU to calculate the AFR ratios as quickly as possible. Now let's understand the symptoms of bad oxygen sensor or faulty oxygen sensor. First one is MIL lamp, that is malfunction indication lamp. Whenever an issue or a fault happens with the O2 sensor, this warning comes up in the dashboard. We can use OBD2 scanner to read the fault codes generated by the ECU and get to know more details on the particular fault. The next one is increased emission. Since the ECU cannot calculate the AFR ratios accurately without O2 sensor, the engine may run in rich condition. Next one is increased emission and increased fuel consumption. Since ECU is not able to accurately determine AFR ratios, engine may run in lean condition or rich condition, both of which will lead to increase in emissions. And when the engine is running in rich condition, the more amount of fuel is being consumed. That's why the fuel economy also drops. Find there is a lag in acceleration or a delayed acceleration. And the other symptoms include stalling of an engine and rough idling. O2 sensors have a very long lifespan of 80,000 kilometers to 1 lakh kilometers. So usually manufacturers recommend to replace the O2 sensor around 1 lakh kilometer range. One more point I want to add, the O2 sensor also starts giving inaccurate values due to the oil deposits or grime, dust which settles on the O2 sensor. Usually these things will be blown away by the hot exhaust, but sometimes if we are running the car only in the cities or if we are running the car at lower speeds, the deposits on O2 sensor may increase. This might give inaccurate AFR readings to ECM. At least once a month or once in 2 months, take your car on a highway and drive the car at 80 km per hour or 100 km per hour for 2 to 5 minutes so that hot exhaust can blow over O2 sensor and remove all the carbon deposits or grime that has been sitting on O2 sensor. That will clean the O2 sensor in a way, thus giving an accurate AFR ratio. You might even see an improved fuel efficiency after doing this procedure. I hope you understood my explanation on O2 sensor. If you thought this video was informative and you learned something, please do like, subscribe to the channel for the future videos, and I'll meet you in the next video. Bye bye.